In the early decades of the 21st century, the United States led the world in artificial intelligence. Its universities produced the breakthroughs. Its companies built the platforms. Its researchers shaped the field. But as AI grows larger, more complex, and vastly more powerful, a new question is being asked. A question that has little to do with clever algorithms and everything to do with the infrastructure needed to run them. Who will power the future? Artificial intelligence is often imagined as something weightless, a cloud, a stream of data, a line of code. But behind every model lies a physical reality, enormous data centers filled with specialized processors consuming electricity on a scale once associated with heavy industry. A single advanced AI cluster draws as much power as a small city. And the demand is rising sharply. Yet, according to a recent U.S. Department of Energy assessment, the American Transition System, the network that moves electricity across the country, is already at full capacity. A RAND analysis reinforces this. The United States struggles to add new power and struggles even more to move it to where it's needed. In the world's most technologically advanced nation, its antiquated electricity grid, originally conceived by Nikola Tesla, has become its most technologically backward bottleneck. The United States does not operate a single national grid. Instead, it's divided into three major interconnections: the East, the West, and Texas, each with limited ability to exchange power with the others. This fragmentation reflects a century of local control, state-level regulation, and incremental development. But it also means that large-scale, long-distance transmission, essential for modern AI infrastructure, is near impossible to build. Permitting can take a decade. Costs are disputed between states. Local opposition can halt projects permanently. The US grid is a system designed for a different era, an era of coal plants, modest loads, and predictable demand. Not for the era of AI. If China succeeds in its national AI ambitions, and if the United States fails to build the infrastructure AI requires, the consequences will be disaster. China would become the world's primary source of computational power. It would set the standards for AI infrastructure. It would shape the global market for advanced technologies, as it's done already with solar panels, batteries, EVs, and high-voltage electricity transmission. American companies could find themselves dependent on foreign compute. National security agencies could face constraints on the systems they can deploy. And the economic gains of the AI era, gains measured in productivity, innovation, and global influence, would shift decisively eastwards. Exactly what Jensen Huang has been warning us about.
At the lowest level energy, China has twice the amount of energy we have as a nation.
I want to ask about that.
Twice as much energy as we have as a nation, and our economy is larger than theirs. Makes no sense to me. However, without energy, how do we build chip plants? computer system plants. And these AI data centers, we call them AI factories. We're building simultaneously 3 different types of factories in the United States. Chip factories, supercomputer factories, and AI factories. They all require energy, every single one of them. Yeah. On the one hand, we want to reindustrialize the United States. How do you do that without energy? At the energy level, back to that stack, we're, 50%. And they're growing straight up. We're kind of flat right now. And so, number one, energy.
The United States has not lost the future, but it has lost time. Rebuilding the grid will require political will, national coordination, and investment on a scale never seen before. Hundreds of times the cost of building AI data centers. It will require new transmission corridors, new electricity generation, and a modernized distribution network capable of supporting all the technologies of the 21st century. The AI race is not a contest of algorithms. It is a contest of infrastructure. And the nation that builds the strongest electrical foundation will shape the century to come. When the story of AI is written in the history books, it won't be a story of software geniuses or venture capital-made trillionaires. It will be a much simpler story of grids, of power, of electricity bills, and of sensible governments. In the age of artificial intelligence, electricity is more than energy. It is capability. It is influence. It is power in every sense of the word. And the question facing the world is simple. Who will control it?